Hello friends, welcome back to the channel, and in this video we are going to learn how we can convert the sequence in time domain into frequency domain using discrete Fourier transform, and we will be using decimation in time fast Fourier transform. So let's get started and let's understand how we can do this process. First of all, we have to take a sequence, and this sequence length will be 8 because we are going to do 8-point DFT using DIT-FFT. So the example is x of n equal to 2, 2, 2, 2, and then we have 4 ones. Just a simple sequence. Now we are going to use a discrete Fourier transform to convert it into frequency domain signal. And so here DIT means that the input signal given to the butterfly diagram which we are going to draw on the paper, the input index should be bit reversal. Now I will tell you what is bit reversal. Here we have the indexes of this sequence, right? So we have index as 0, 1, 2, 3, 4, 5, 6 up to 7, right? Now we will write the equivalent of all these numbers in binary form, and we will write it in 3 digits. It will be 0, 0, 1, and again here we have 0, 1, 0, 0, 1, 1, 1. Now what we will do is we will do the reverse of all of these digits. So we will take reverse. So for zeros it will be the same. For 1 it will be 100. 1 for 7 it will be same. Now we will write the decimal value of all these binary numbers. So these are the index values of the sequence, and in this sequence only the input should be, these all inputs should be given to the butterfly diagram. I hope you understood this bit reversal concept. Now let's draw the butterfly diagram for 8-point DFT using DIT-FFT. So on this page I have drawn 8 lines over here. You can see it 1, 2, 3, 4, 5, 6, 7, and here I have the 8th one. If you're not able to see, I'll just zoom out. So yeah, we have 8 lines over here. Now as we have took the bit reversal order, so the first input to this line will be x of 0, the second one will be x of 4, x of then 2, and x of 6, x of 1, x of 5, x of 3, and then x of 7, right? So these inputs are taken in bit reversal order. So this is DIT, decimation in time. That means the input values of time domain should be in bit reversal order. Now we will draw the butterflies on this side. We will be drawing on the entire page itself, but on the left hand side we will be drawing independent butterflies, and as we move towards the right hand side we will be overlapping one butterfly on another. So I'll tell you how. First let's start on the left hand side. Here we will be having an independent butterfly, so this represents one butterfly, okay, and this is the head of the butterfly, this is the tail of the butterfly, and the data flows like this from left leg to the right top, and from left top to the right leg. In the same manner we will be having another butterflies on the bottom, and we will follow the same thing. The data will flow like this, and the top will be having 1 and the bottom will be having -1. This represents one butterfly, and again in the same manner we will draw the same butterflies and we will give same labels on all the butterflies. So I have done that thing. Now we will be moving towards the right hand side. As we move right hand side, we will be overlapping one butterfly on the another. How we will do that? First, let's consider that this is the left top of one butterfly. Then we will be leaving one line, and then we will be ending that line over here like this, and the data will flow like this in the same manner. So this is the left bottom of the butterfly, and this is the right top of the butterfly. So the data will flow like this, and this is represents one butterfly. So this is the top of the butterfly, face of the butterfly, which will be having 1, and the tail should have -1 on the bottom. So this represents one butterfly. Now how will I overlap one butterfly on the other? We have drawn one butterfly. Now we will draw another butterfly over it. So this is another butterfly which is on top of this butterfly. You can assume it like that. So this is the top of the butterfly, which will be having 1, and the bottom will have -1, and the data will flow in the same manner from top to bottom and from here bottom to top. Right? You have understood? Now what about the remaining one? We will be copy pasting the same thing on these 4 lines. So we will draw it, it will be ending here. So we will draw it like this. Yeah, this is the top, this is the top, this is the bottom, and this is the bottom. Sorry, it got a little bit clumsy. Just ignore this one. So yeah, here we have top and bottom, and the data flows like this, and the data flows like this. So this represents 2 butterflies, and here one is overlapped on the another butterfly. Perfect. Now as we are moving towards more right hand side, we will be overlapping more butterflies on the another. Now here we left only one line, and we ended up another leg of the butterfly on the third line. Right? Now we will be leaving 3 lines, and then we will be ending the tail of the butterfly. How we will do that? We will start from this line, and we will leave 1, 2, 3 lines, and we will end up over here. So a straight line, and if the ending is this top, then we will start from this. So this represents a big butterfly, and this is the top and this is the bottom. I hope you are understanding whatever I am explaining. So the data flows like this, the data flows like this. Now we will overlap one butterfly on the another. So we will start from here, we will end it on this line, we will start from here, and we will end it up on this line. So this represents another butterfly. The top is 1, the bottom is -1 again. And this fourth line is the top, and the last line is the bottom, and the data will flow in the same manner on the butterflies. So we need to draw arrows also. Perfect. So this is the final butterfly diagram. I hope you are able to see it clearly. Right? Now what we need to do, we need to consider on the left bottom of the butterfly, we need to take W, and what is the capital N value? 8, right? So 8 of 0. On all the left bottom of the butterflies, we will take W8 of 0, and here on this butterflies, we will consider W8 of 0 on this leg, 8 of 0 on this leg, and W8 of 2 on the second butterflies, which is on top of the another butterfly. In the same manner, here we will take W8 of 0, and here W8 of 2. and what is the value of this W8 of 2 or W8 of 0, you can understand it if you have saw my previous video on this 4-point DFT butterflies, right? So now on these bottoms we will take again the W values: W8 of 0, W8 of 1, W8 of 2 and W8 of 3. Perfect. Now let's derive the value of all this. Let's take another paper. I have it over here. So W8 of 0, how we are calculating it? This is equal to e to the power of minus j 2 pi by 8, and the k value is 0. So basically the formula is Wn and Nk is equals to e to the power of minus j 2 pi by n, and here we have k. So here we will get e to the power of minus 0. So minus 0 doesn't exist. E to the power of 0. So final value will be 1. W8 of 0 is equal to 1. Now W8 of 2, right? So for 2 again we will expand this formula, and 2 pi capital N is 8 and k is equals to 2, right? So we'll cancel this one and we get this. So e to the power of j pi by 2. So if you calculate this in Calci, you will get this value as minus j. Perfect. And if you don't know how to calculate these exponential values in Calci, then you can prefer to my previous video in this playlist, in which I have explained you how you can calculate exponential values in Calci. So yeah, we have evaluated the value for this, and let's go to e to the power of now let's go to W8 1. So we will get e to the power of j, and 2 pi by capital N is 8 and k is equals to 1. So it will get cancelled as this, and we will get e to the power of minus j pi by 4. So this value we will get it as 1 by root 2 minus j and 1 by root 2, or you can write it as 0.707 minus j 0.707. Both are the same thing. Okay, now let's evaluate this k value for 3. So we will get again e to the power of 2 pi by capital N is 8 and k value is 3. So this will become 4, and we will get e to the power of 3 pi by 4. So we will get the value over here is minus 1 by root 2 and then minus j 1 by root 2. So this will become 0.707 minus j 0.707. So these are all values of W0, W1, W2 and W8 of 3. Now let's just zoom out a little bit so that you can see the entire paper. Here I need to take a different color pen. Let me take that first. Yeah, so I have a red color pen. So now we will be writing all these values. This is equal to 1, 1, 1 and 1. This is 1, and this value is equals to minus j. This is 1, this is minus j, this is 1, and this is 1 by root 2 minus j 1 by root 2. This is equal to minus j, and this is minus 1 by root 2 minus j 1 by root 2. Fine, everything all set. Now here we have input in time domain, right? And why are we doing this discrete Fourier transform? To convert time domain into frequency domain, right? So here we have time domain, and here on the output we will be having the output in frequency domain, and for the output the sequence will be in normal order only. It will be x of 1, 2, 3 up to 7, 5, x of 7. Perfect. So this is the sequence of the output. Now we are entering into the evaluation process for all the values, and we will take the values, we will multiply with the things which are in the middle, and then we will evaluate the final result over here. So here, if I will take the input things over here. So really sorry, I took the sequence in reverse order. So these all 2's are 1's and all 1's are 2's, and I'll write it in a clear manner so that we don't get confused while calculating the answer. Yeah. So now let's start the operation. I mean, not that doctor wala operation for calculating all these things. Take it as too complex. We will maintain results of this first stage. Let's say from here we have first stage 1 result, and this until this point we will have stage 2 result, and the final stage 3 result we will maintain on another paper. So we have this paper, right? So we will maintain the result on this paper. So let's write it down over here. And this is the input which we have over here. So the input is 2 1 2 1 2 1 2 and final is 1. Perfect. Now here we have 2 on the first butterfly. Let's concentrate on the small butterflies. So here we have 2. The 2 will be moving like this, and to this point it will come 2. Now from the bottom leg we will take 1 into 1 and into minus 1. It will be minus 1. So plus minus 1. What you will get? Equal to 2 minus 1 equal to 1. So the final value on the this second index we got is 1. And here again we will take 2 and into 1. So we got 2. And from here we will take 1 into 1 and it will go like this. So plus 1 we got equal to 3. Perfect. Now let's calculate for the second butterfly. Here 2 into 1 equal to 2, plus from the bottom it will come 1 into 1, so equal to 1. So it will be equal to 3. Now from here 2 and directly it will come 2 plus 1 into 1 into minus 1. So again it will be 1. So here again we have 3 and 1. In the same manner, if we take over here 2 into nothing is 2, again here 1 into minus 1 is minus 1, so we will get 1, and in the same manner 2 plus 1 it will become, so 3 and 1. In the same manner for the bottom butterfly also we will have 3 1 3 1 3 1 and 3 1. Perfect. We have maintained the results for stage 1. Now let's move on to stage 2. We have value as 3. Now 3 will be moving to here. We have 3 into 1 is 3, right? So nothing. Now here we have 3 into 1. So 3 into 1 is 3. It will be moving on the top, and plus 3. Here again from here we will take 3 and nothing is getting multiplied. We have 3. From here we have 3 into 1 into 1 minus 1. So we will get minus 3, right? Plus minus 3. What it will be? It will be 0. From here we will get 1 and multiplied by 1 is 1, plus from on the bottom 1 into minus j and nothing getting multiplied, so we will get minus j. So we got 1 minus j. So let's write it down here. We got 6, we got 1 minus j, and we got 0 on the bottom. So from here we got 1 and it will travel like this, nothing getting multiplied. We got 1 and plus. From here we got 1 into minus j, right? So it will get minus j. Minus j into minus 1, we will get plus j. So it will be 1 plus j. Now let's move on to the next butterfly over here. I think that the result will be exactly same. So let's just write it down. 6, 1 minus j, 0 and 1 plus j, and let's maintain it on this paper. So it is 1 plus j, and here 6, 1 minus j, 0 and 1 plus j. Now let's move on to the final stage. So here we have 6. So 6 will be traveling over here. 6 into 1 is 6, plus from this line 6 into 1, again we will get 6 plus 6, final is 12. And from here, if we go on the bottom side, 6 into nothing, 6, and from here 6 into 1 into minus 1, what will we get? Minus 6 is 0. Now on the second line, 1 minus j multiplied by 1 will be 1 minus j only, plus from this line we will get 1 minus j into 1 by root 2 minus j into 1 by root 2. So we have to multiply this thing. So we have 1 minus j, and we have 1 by root 2 minus j into 1 by root 2, right? So we have minus root 2. So this value is 1.414, right? And we have j. Now this is the final output for this multiplication, and again we are multiplying it with minus 1, right? So we will get plus 1 by 414 j, and if we are moving towards this side, we will get here 1.414 j, and from here we will be getting plus 1 minus j. We will get 1 and plus 0.414, right? I hope you got this. And on this side, here we got minus 1.414. So this is minus, and we have j, so these both will get minus 2.414, and the final value will be 1 minus 2.414 j. In the same manner, let's calculate for this point. We have 0 multiplied with 1, we will get 0, plus from on this bottom side we have 0 multiplied with anything will be 0, so we have 0. And on this line we have 1 plus j, and into 1 we will get 1 plus j, and plus from this bottom we will get 1 plus j into this thing, and we will get on this line. So what do you think we will get? Let's calculate that thing. So if we have 1 plus j, and we have minus 1 by root 2 minus j 1 by root 2, so finally we got root minus 2 root 2 into j. This is minus 1.414 j, in the same manner that we got over here. So now we will move on this side, so we will get minus 1.414 j. So finally we got 1 minus 0.414 j. Perfect. Now we are left with 1 and 2, I mean x of 6 and x of 7 we have to calculate. So from here we will get 0, and from here we will get 0 into minus j into minus 1, so that is same thing. And for x of 7 value, we are getting 1 plus j from this line, that is 1 plus j, and from this line, bottom line, we are getting this into this and into minus 1. So we got this minus 1.414 for these two values, and into minus 1 we will get 1 plus 414 j, right? 414 j. So we will get 1 plus 414 j, and finally we will get 1 plus 2.414 j. So this is the final answer. Now let's note it down, all the values of the indexes. So x of k will be equal to, first index is 12, next index is 1 minus 2.414 j, and the next index is 0, and the next is 1 point j into 0.414. The next index is again 0, and the next index is 1 plus 0.414j. The next index again is 0, and the last index is 1.j into 2.414. So this is the final sequence which is in frequency domain. So we have successfully converted the time domain signal into frequency domain signal using discrete Fourier transform using DIT-FFT, that is decimation in time fast Fourier transform. So this is the final result for 8-point DFT using DIT-FFT. I hope you understood whatever I have explained in this video, and if you want a recap, I'll give you a recap, small recap. So first we have to take the inputs in bit reversal order in DIT case, which is decimation in time case. So we have to take the input in bit reversal order. The output will be in normal order only, and we have to take butterflies like this, and as we move towards the right hand side, the butterfly will overlap on another butterfly. So first we drew only one butterfly independently. On the next line we drew one butterfly on the another. Also we have to consider W8 of 0, W8 of 2 values. So on this independent butterflies we will have W8 of 0. On this 2 butterflies we will have 0 and 2, and this on the final 4 butterflies we will have 0, 1, 2 and 3 in sequence. So here you can see 0, 1, 2, 3 in sequence. Perfect. I hope you understood whatever I have explained in this video, and also we took a small recap. So for that thing, I hope you will like the video and subscribe to the channel for more such amazing explanations. And if you have any suggestions for me, then you can put it down in the comment box. And yeah, thanks for watching.